So for example, see here, one of the male students is named David. How many six-member selections consisting of David, one other male, and 4 females are possible? So here we're going to talk about, so there's only, how many ways are there to select David? So here there's only one way to select David. Oh, just to select David. And then what you can ask yourself is, okay, so now we need to choose one other male. So how many males can we get? So if there was 9 before, we selected David, he was obviously a male. So that means that there are 8 left, so that means that there's 8 ways to choose a male. And then for females, there are 8 females in total, and we're only picking 4 of them. So this one here we're going to be using combinations. So this one here we have 8 in total, and we're going to choose 4. So putting that into our equation there that we know, that is 8 factorial divided by 8 subtract 4 is 4 factorial. R was 4. And if you guys solve that out or put it into your calculators, you guys will find that that is equal to 70. And then, just like before, we're going to multiply the different ways. So to get the possibilities, it'd be the number of ways to select David, so it'd be 1, times the number of ways to select a male, which is 8, and then the number of ways to select 4 females, so that'd be 70. Multiplying 1 times 8 times 70, that you guys should find is 560 different ways to select David, 1 male, and 4 females. Okay? So now we're going to talk about combinations with cases. So to solve problems, count the different combinations in cases that together cover all the possibilities. You calculate the number of combinations for each case and then add the values for all cases to obtain the total number of combinations. So this is probably going to sound pretty much the exact same as permutations when we had different cases. And it really is. The only thing that you're using is the combination equation instead of permutations. And then so you just add each case when you find out the total possibilities. So it's pretty similar. So we need to look at the different kinds of cases, and that's looking at different keywords like at least, minimum, maximum, all of those kinds of words that could present different cases. So looking at example number 1 here, an emergency response team of 4 people is selected from a group of expert volunteers consisting of 2 doctors, 3 surgeons, 3 firefighters, and 4 nurses. In how many ways can the team be chosen if it must contain at least 3 nurses? So here's that keywording, at least 3 nurses. So that means that there's going to be a bunch of different cases. And if you can't see that just yet, we're going to have 2 different types of cases. So just as a reminder there, so the team is of 4 people. So our first one is when we actually do have 3 nurses. So it'd be case number 1. So when we have 3 nurses. And our second case is when we have 4. So at least, so then we're going to go up 1. So then we'll have at least 4 nurses. We wouldn't go up because our groups are only of 4 people, so we wouldn't go any higher than that. So what you're going to do is you're going to find the number of ways to choose 3 nurses, and then the possibilities for 4 nurses, and add those 2 possibilities together. So for case number 1 here, we'd have 3 nurses and 1 other person. It didn't specify who this other person was, it's just 1 other person. So to write our combinations there, we're going to be looking at, we're going to multiply the 2 together, so we'll find the combination for nurses and then the 1 other person. And that one will be, we have 4 nurses in total, that's what it says right here. So there's 4 nurses, and we're choosing 3 of them. And we're going to multiply that with the combination for the other person. And so you're going to look at, okay, well, who is left? Or what number of what total people is left over. So we have 2 doctors, 3 surgeons, 3 firefighters. So that's 2 plus 3 plus 3. So that's 8 people in total. So we're taking a total of 8 people, and we're going to choose 1 person. Okay, then using our formula, we have 4 factorial. Divide that by 4 minus 3 is 1 factorial. And then times it by r factorial, which is 3 factorial. And we're going to multiply that with 8 factorial. Divide that by 8 minus 1 is 7 factorial. Times that by r factorial, which is just 1 factorial. Now going back, if you guys want to, you guys can put this into your calculators, or if you remember from last session, we can simplify, or we can expand 4 factorial to be 4 times 3 factorial. Then 3 factorial in the denominator will cancel out with the 3 factorial in the numerator. So what we're left with is just 4 divided by 1 factorial, which is 1 factorial is just 1. So that one is just 4. And same thing is going to happen with our 8 factorial and 7 factorial. If, say, we had n factorial divided by n minus 1 factorial, you're just left with n. So here we're just going to be left with 8. So 4 times 8 there is 32. So that means that there's 32 different ways that we can choose 3 nurses and 1 other person. So moving on to case number 2 there. This is when we have just 4 nurses. So we're choosing 4 nurses and 0 others. So remember, it's that keyword at least. So we could have at least 3 people, but we could have more. But there's only a team of 4 people, so we wouldn't go any higher than that. So using our formula, and if you guys want to, you guys really don't need to do the math for this, because there's only one way to choose 4 people from 4 people. So there's only way to take those 4 people. So you really don't have to do the math. But if we want to, just to double check, let's put this into our formula there. So we have 4 people, or 4 nurses, and we're going to choose 4 of them. And we don't need to create one for 0 others. So putting this into the formula, we have 4 factorial. Divide that by n minus r, so it'd be 4 minus 4 is 0 factorial. And times that by 4 factorial, which is r. So looking at this, 4 factorial will cancel out with 4 factorial. And 0 factorial is just 1. So it'd be 1 divided by 1, which is just 1. So there's only one way to choose 4 nurses from 4 nurses, if you guys couldn't see that yet. Alright, and then so now we need to combine these 2 cases. So what we're going to do is, just as we did earlier, we're going to add the 2 cases together. So we have 32 plus 1. That means that there are 33 ways to choose at least 3 nurses. Alright, so if you guys are good, let's move on to the next example there. So number 2 here is asking about a bag that contains 7 black balls and 6 red balls. And how many ways can you draw groups of 5 balls if at least 3 must be red? So there's that keyword there. There's at least 3 must be red. So what kind of different cases are we going to have? Well, the first one we start off with is when we have that minimum of 3 balls. So case number 1 is when we have 3 red balls. Then the other case that we could have is case number 2 is when we have 4 red balls. And then our last one is when we have 5 red balls. Alright, so we can go up to, this one here is groups of 5, so the maximum we can do is 5. And we also have 6 red balls in total, so that means we can go up to that maximum of 5. So say for example, what if we only had 4 red balls? Then we wouldn't be able to have this third case. So I guess one thing is to check, first of all, how many groups or how many balls can you have in a group, and then make sure that you have enough red balls to fit all those cases. So here we have 6, we have enough to meet all of these cases, so that's great. So let's start with case number 1. So this is when we have 3 red, and what will be left over? We'll have room for 2 more, and our only other case there is with black balls. So there'll be 2 black balls. Putting that into, let's find those combinations there. So we have 6 red balls in total, and we're going to choose 3 of them. Then we'll multiply that with, we're going to have 7 black balls in total, and we're going to choose 2 of them. Putting that into our equation there, we'd have, or into our formula, we'd have 6 factorial over 6 minus 3 factorial is 3 factorial, times that by r factorial, which is just 3 there. Then we're going to multiply it with our combination formula there, so we'll have 7 factorial, divide that by 7 minus 2 is 5 factorial, times that by r factorial, which is 2. Then we can solve. So multiply those, or we can find out those numbers at least. So 6 factorial, divide that by 3 factorial, times 3 factorial. That one there we should get 20. And then we have 7 factorial, divide that by 5 factorial times 2 factorial, and we should get 21 for that one. So you guys can put that into your calculators there. And sorry, I guess it's going to be a little bit cramped. Hopefully you guys have more room than I do. I got my big giant monster writing out here, so hopefully you guys will have more room there. Okay, and so multiplying those two numbers together, we should find that there are 420 different ways to select 3 red balls and 2 black balls. Alright, so for our second case here, we have 4 red balls. And what would be left over? We'd have room for 1 more black ball. So creating those combinations, we'd have 6 red balls that we can choose from, and we're choosing 4 of them. Multiplying that with, we have 7 black balls to choose from, and we're going to choose 1. Making that into our formula there, we have 6 factorial. Divide that by 6 minus 4 is 2 factorial times r factorial, which is 4. Then we're going to multiply all of that with 7 factorial divided by 7 minus 1 is 6 factorial times it by 1 factorial, which is equal to, if you guys put this into your calculator, we should have this combination here should equal 15. And this one here, if you guys can see that already, this one here should be 7. So 15 times 7 there is 105. So there are 105 different ways to choose 4 red balls and 1 black ball. And so for our last case there, we have 5 red balls and 0 black. Now this one is not so obvious as say the last example, because the last one we had 4 nurses and we were choosing 4 of them. This one we're choosing 5 red balls, but there's 6 in total, so we still have to set up this equation. So we have 6 in total that we can choose from, and we're going to choose 5 of them. Putting that into our formula there, we have 6 factorial. Divide that by 6 minus 5 is 1 factorial, times it by r factorial, which is 5. Then if you guys can see this, it is our bottom here is 1 less than our numerator there. So we should have a product, or when you put that into your calculator, we should get 6. So there are 6 different ways to choose 5 red balls and 0 black balls. So now we found the possibilities for each case. Now we're going to add them all together. So we'll have 420 from our first case, plus 105 from case 2, and 6 from case 3. Putting that into your calculators, we should find that there are 531 different ways to choose at least 3 red balls. Okay? So there's 531 ways to choose at least 3 red balls. Alright.